Hello everyone, welcome to Chaudhary Data World channel. Today I am here with topic on Pyspark that are cache, persist and checkpointing. All these topics are related to increase the speed of execution of any transformation into our Pyspark code. We'll be watching in all detail that what it is all about, and at last we will also be checking how we can demonstrate and how we can uh, prove that cache, persist and checkpointing, all these three are used for increasing the speed of our code. So let's get started with the video. First one is cache. So cache is nothing but it's suppose if you can visualize all these three in a chunk, that whenever any particular data set or data frame or RDD, mainly RDD and data frame, whenever it is getting stored into the local memory of the virtual machine. If you are already aware of the architecture of a Spark, in that the last tier is executor node. That executor node is having its own local memory. If the data set or the RDD or data frame, it is getting stored into the local memory of the virtual machine, so that is, in whole term, it is called as caching, persisting or checkpointing. All these three relates to that concept only, but these three differs in a bit in each of them by having some of the differentiation between them. That we will be watching one by one. First one is the persist. So persist is nothing but if suppose you want to have again cache your local data. That means if you want to store that data into your local memory, then persist is the method with which you can do it. But what's the difference between then persist and then moving ahead the cache? Cache also does the same work. The difference between both cache and persist, if you want to see, that it is having the level of storage and flexibility of caching options. That means in persist we are having multiple level of caching options, or we may say that multiple level of storage. So what all level of storage, what is even level of a storage? So since it is storing all the whatever you are having data set or RDD or data frame, that is getting stored into the local. That local memory are of different types. That means memory only, memory and disk. Memory and disk, if you are aware of that, what is memory and disk? So memory you can visualize it as RAM, and disk you may visualize it as HDD, hard disk drive. So this memory only SER is serialized. Put the data into memory, but put it into the serialized format. Disk only means you want to just keep your local data set or data frame, whatever you are having, into the disk only. After that, off it is again a different concept. We means these are the different level of storage, we may say, altogether, with which we can have options to store uh, into the persist method. But in cache method there is no any flexibility to change that different level of storage. That means if it is having the default level of storage, that is memory only, it will be memory only. That means the data, if you want to or data set or the data frame, whatever you want to store into the local memory, that will be into your memory only. That means it will be into your RAM only. It can't be saved into your disk. If suppose that data set, whatever you want to store, is overflowed into the RAM. Suppose your RAM is of that virtual machine is of suppose 4 GB, and your data set is approximately around 8 GB. Then in that case it will throw error. It can't handle that situation. That's why cache is a bit less flexible in this means, and persist is the well established, or we may say that most reliable method with which we can store our data into the local. So with that we can change our level of storage as well. For that we just need to do whatever data frame you are having dot persist, and then define the storage level dot memory and disk, storage level dot memory only SER, whatever you want to have, that you can pass it as the argument. use memory and disk storage level explicitly, means whatever you want to define the level of storage, you need to define it explicitly for in the persist. That's why it's the most dynamic one, most flexible one. Now coming to the checkpointing, that if these two are having are already there, cache and persist into the Pyspark concepts, then why even checkpointing is in the picture then? Checkpointing is nothing but it's a different way to store your whole RDD or the data frame into your local. It's not like that it will simply just keep that whatever you are having data frame or RDD into your local. It will just create if you are aware of lineage of the transformations whatever you are applying into the data set. So those lineage wherever you are giving dot checkpoint, means whatever on whatever RDD or whatever data frame, after suppose you are having 10 transformations into your whole of the into the PySpark code. So after 5 transformation, if you are doing that particular data frame or RDD dot checkpoint, that means that or at that place only, for at that data frame or the RDD only, it will be lineage will be breakdown, and it will be kept into your local memory. It will not be kept it is something which is very beneficial when you want to have fault tolerance. I will be explaining you how we can do have fault tolerance ahead into some of the video in detail. So you can just visualize it like that, that it will in between whatever the line is having different sets of RDDs of different transformations, but in between for a single RDD, if you want to have checkpoint over that, that RDD can be saved into your local memory. And it is again having the drawback that it's having the default method of on memory. It uses memory and disk. It's as the this one as the default option, memory and disk, but we can specify different storage level when we are calling the checkpoint. Means so you can explicitly call whatever you want to have this different level of storage, but by default memory and disk is over there. So this was whole story of this cache, persist, and checkpointing. Now we will be moving to the Databricks, where we can have a demonstration, clear demonstration, in which we will be proving that how cache is improving our performance and how it is reducing our execution time. All these things we will be watching over here. First one, we will go with persist. In this persist, you can see that we are importing one RDD versus DF. This is a suppose some text file it is over here into our file stores slash tables in this path, for which what we are doing, it is containing a string. This RDD versus df.txt is containing a big string. That big string is then we want to count that what number of words it is into that particular .txt file. For that, what we are having this particular chunk of code which is just counting it. But here what we can see that it is hashtag without persist. That means it is the chunk of code which is demonstrating that it is without persist. That means in this particular chunk of code, it is counting the words into that txt file, but without persist. For that, what we have done, we are calculating the elapsed time, so that we can have a clear demonstration that which particular one. That means if persist if we are using it is taking less time than the without persist. So in the next line of code it is with persist, that you can see that here uh, uh, we are taking the count. After count, you first in the very first line only you can see that lines dot persist. That means it has been cached, or you may say that stored into the local storage by having this dot persist. Now when it is into the local, after that it is having applied those whatever sets of transformation, that is dot flat map or whatever it is over there, it is getting applied, then count is being taken. After that, elapsed time is getting calculated. So one in both of the scenarios we will be watching that how much is the elapsed time in counting that whole words into that whole string, or you may say .txt file. So for that we will just click on shift plus enter, so that it should give us the result in elapsed time. So you can see here that both of the counts are same, that is 9, but elapsed time with dot persist, it is 3.29, and you can see the clear difference, and it's a huge difference, right? That elapsed time with persist, that means if you have stored that whole data set into your, or the RDD, whatever it is having, lines is here, what you can see here, it's a data set, right? So it's, this data set is getting persist, means it's been stored with by this dot persist method. So now when it is getting stored into the local storage, after that the elapsed time is only 0.67. So it's a huge difference between 3.29 and then 0.67. This is the beauty of this persist method. Moving ahead with another example. Another example is of, again, it's of persist only. We will be leaving it ahead. We will moving it to cache. So in this cache, you can see that we can just remove this off because there is already a Spark session created into our Databricks. No need to create it explicitly. So here you can see that in cache, again we are having two sets of code. This particular set of code is without cache. This particular set of code with cache, the same thing it is going on, whatever it was into persist. It is also counting the number of words, whatever consisting getting consisted by this .txt file. For that, when we are again taking the count and then elapsed time, click on shift plus enter, you can see that count with without cache it is 9, right? And elapsed time is 0.507. Okay, and it, let me run it again so that it can have a, so you can see that count with cache and with without cache, in both of the cases you may see that it is giving you the result in the time, how much time has been elapsed into it. But without cache it is 0.417, and with cache when you are doing it 0.4675. So this is how this is cache is going on here. This time you can see that it is now on with cache, it means it also depends on some of the computation. You saw it, right, that two times when I have uh, uh, run this particular code, it was giving without cache as the less time and with cache as the more time. But this time you can see clearly that it is count with cache. Since the data set is very small, that's why the computation is not that much accurate. If you will take up the large data set, you can see then the clear difference. Here you can see that 0.46 only time it is getting elapsed without cache, and then 0.5 as the time with cache. So moving ahead with the checkpoint, in this checkpoint what we are doing, it's not straightforward as like persist or cache. Whatever things are there, we are dumping it into the storage, local storage. It is getting done into cache and persist. But in checkpoint we are specifying that which RDD and which transformation we need to store that which data set into our local storage. So that we are specifying it over here by having, you can see that lines dot checkpoint, correct? So this lines is there, and this only we are storing into our local storage. So as soon as we click on shift plus enter, you can see that without checkpointing it's 0.04. Since the data set is very small, so it also depends on the various things. If you will do 2 to 3 times, you may see that it has been decreased to 0.033. But into when we were without checkpointing, we are watching that it is execution time is taking 0.41. So this is all about how we can do our caching and then persist and then checkpointing. All these three, how we can perform and how it is dependent on our or you may say it is directly influencing our code performance. So this is how we can apply it into the real scenario. So hope you found this video very helpful. If you found it helpful, kindly like to the video, subscribe to the channel. Thank you so much guys for watching the videos. Stay tuned to the channel for upcoming videos.